September 3, 1943, Jever Airfield, northwestern Germany. Oberleutnant Klaus Brenner adjusted his leather flying helmet and squinted through the morning haze at the intelligence photographs spread across the briefing table. The images showed a peculiar American fighter, grotesquely thick-bodied, stubby-winged, and ungainly. His fellow pilots of Jägerschwader 11 crowded around, their laughter echoing off the concrete walls of the hastily constructed briefing room. "Mein Gott," chuckled Hauptmann Werner Schroer, tapping the photograph with a gloved finger. "The Americans have built a flying bathtub. Look at this thing, it's enormous." Brenner nodded, his confidence as unshakable as the morning frost on his Focke-Wulf's wings. After all, his nimble Foix 190 could dance circles around anything the Allies had thrown at them. The sleek lines of German engineering had proven superior time and again. What could this lumbering American contraption possibly do to change that? What Klaus Brenner could not comprehend, as he dismissed those grainy reconnaissance photos with casual arrogance, was that he was staring at the physical manifestation of American industrial supremacy, a weapon system that would systematically dismantle the Luftwaffe's carefully cultivated myth of technological superiority. The Republic P47 Thunderbolt wasn't just another fighter aircraft. It was a 14,000-pound sledgehammer of steel, aluminum, and overwhelming firepower, backed by the incomprehensible productive capacity of a nation that had transformed its entire economy into a weapons manufacturing apparatus. This wasn't merely about aerodynamics or pilot skill, this was industrial warfare incarnate, where victory would be measured not in the elegance of design, but in the crushing mathematics of mass production, sustained logistics, and raw, unrelenting firepower. The German pilots' mockery was understandable, even rational, given what they knew. The Thunderbolt appeared to violate every principle of fighter design that had governed aerial combat since the Great War. Where German fighters were svelte and minimalist, the P-47 was massive. Where the Messerschmitt Prof. 109 weighed a modest 5,600 pounds fully loaded, the Thunderbolt tipped the scales at a staggering 14,000 pounds heavier than many medium bombers of just a few years earlier. The numbers seemed to tell a story of American engineering incompetence. The FW-190 could climb at 3,000 feet per minute. Early P-47 models managed barely 2,000. In turning combat, the German fighters could outmaneuver the American behemoth with embarrassing ease. Brenner's confidence wasn't misplaced, it was mathematically justified by every conventional metric of fighter performance. But mathematics, as the Germans would learn, could be devastatingly deceptive. The first hint of what was coming should have been visible in Republic Aviation's factories. While German aircraft production in 1943 peaked at 25,000 fighters annually, a remarkable achievement for a nation under constant bombardment, American factories were preparing to unleash something unprecedented in the fighting history of warfare. The Farmingdale plant alone was rolling out P-47 seconds at a rate of 350 aircraft per month by late 1943, and this was just one of multiple production lines. The Curtiss Wright factory in Buffalo was producing R-2800 engines at a rate of 1,200 per month. The sheer scale was incomprehensible to German industrial planners, who were fighting constant battles over raw materials, skilled labor, and fuel allocations. The statistical reality was staggering. Republic Aviation would ultimately produce 15,683 P-47 Thunderbolts, more than the entire lifetime production of all German fighter variants combined. But raw numbers told only part of the story. Each Thunderbolt represented a level of technological sophistication and ruggedness that German engineers, constrained by material shortages and rushed production schedules, could only dream of achieving. The R-2800 double Wasp engine alone was a masterpiece of American engineering, 2,000 horsepower of supercharged, turbocharged fury that could operate at power settings that would have destroyed German power plants within hours. Where German fighters were built like precision racing cars, optimized for performance but fragile under stress, the P-47 was engineered like a Sherman tank with wings. The fuselage structure could withstand G-forces that would have torn apart a Messerschmitt, The self-sealing fuel tanks could absorb dozens of machine gun rounds without catastrophic failure. The pilots sat behind armor plating thick enough to stop 20mm cannon shells. This wasn't just ruggedness, it was systematic survivability, designed by engineers who understood that in industrial warfare, the aircraft that comes home is the aircraft that can fight again tomorrow. Then there was the firepower. 8 Browning M2, 50 caliber machine guns, each capable of firing 750 rounds per minute. This wasn't just impressive, it was revolutionary. German fighters typically carried 2 20mm cannons and 4 rifle-caliber machine guns, providing devastating punch in short bursts but limited ammunition capacity. The Thunderbolts' 50 seconds could pour out 6,000 rounds per minute of sustained fire, turning the aircraft into a flying weapons platform, capable of destroying ground targets, bombers, and fighters with equal lethality. Each 50 caliber bullet carried nearly 4 times the kinetic energy of German rifle rounds, and the Thunderbolt carried 3,400 of them, enough ammunition for sustained combat that could last minutes rather than seconds. The transformation of American pilots into Thunderbolt warriors revealed another dimension of American superiority that German intelligence had catastrophically underestimated. While the Luftwaffe was burning through experienced pilots at an unsustainable rate, American training programs were producing aviators with 200 to 300 hours of flight time before their first combat mission, more training than many German aces received in their entire careers. These weren't desperate teenagers pressed into service. These were thoroughly trained professionals who understood their aircraft's capabilities and limitations with scientific precision. Lieutenant Colonel Francis Gabby Gabreski, flying with the 56th Fighter Group, would eventually become the leading P47 ace in Europe with 28 confirmed kills. But Gabreski's success wasn't just about individual skill, it was about systematic tactical evolution. American pilots learned to exploit the Thunderbolt's advantages while avoiding its weaknesses. They refused to engage in turning dogfights where German fighters held the advantage. Instead, they developed boom and zoom tactics, using the P-47's superior high-altitude performance and diving speed to engage on their terms, striking with overwhelming firepower and then using their superior dive performance to escape before German fighters could respond. The Thunderbolt's performance at altitude was where American engineering superiority became most apparent. While German fighters suffered from inadequate supercharging and struggled to maintain power above 25,000 feet, the P-47's turbocharged R-2800 actually improved its performance in the thin air of high-altitude combat. At 30,000 feet, where German fighters were gasping for power, the Thunderbolt was in its element, faster, more maneuverable, and deadlier than anything the Luftwaffe could field. This altitude advantage became crucial as the war progressed and American bombers began operating at increasingly high altitudes to avoid German interceptors. The psychological impact on German pilots was as devastating as the physical destruction. Hauptmann Johannes Steinhoff, one of Germany's most experienced fighter pilots, would later describe the horror of facing Thunderbolt formations. They came at us like a bronze avalanche, dozens of them, impossible to count. We would climb to intercept the bombers, and suddenly the sky would be full of these enormous American fighters, pouring down from above like falling hammers. The sound of their engines was like thunder, hence their name. But it was the sound of their guns that haunted our dreams. 8 machine guns firing simultaneously creates a sound unlike anything else in warfare. A continuous roar that drowns out engine noise, radio communications, even thought itself. The statistics of destruction began accumulating with mathematical inevitability. In October 1943, the 56th Fighter Group, flying P-47 seconds, claimed 85 German aircraft destroyed in air combat, while losing only 11 of their own, a kill ratio that represented not just tactical superiority, but systemic dominance. These weren't lucky engagements or statistical flukes. They represented the culmination of superior aircraft, superior training, superior tactics, and most importantly, superior logistics that kept American squadrons at full strength while German units withered away through attrition they could not replace. The production numbers told a story of industrial warfare that German planners had never conceived possible. By 1944, American factories were producing P-47 seconds at a rate of nearly 1,000 aircraft per month. Meanwhile, German fighter production, despite heroic efforts by engineers and workers operating under constant bombardment, peaked at barely 2,000 aircraft per month for all fighter types combined. The mathematical reality was inescapable. America was producing Thunderbolts faster than Germany could train pilots to oppose them. But the true revelation of American industrial supremacy came not just in aircraft production, but in the systematic support infrastructure that kept those aircraft operational. While German squadrons scrounged for spare parts, fuel, and ammunition, American P-47 units operated with logistical abundance that seemed almost magical to their opponents. Each Thunderbolt squadron was supported by dedicated maintenance crews, with comprehensive spare parts inventories, unlimited ammunition supplies, and fuel allocations that allowed for extensive training and operational flexibility. German pilots frequently found themselves grounded, not by enemy action, but by the inability to obtain the basic supplies necessary to keep their aircraft operational. The Thunderbolt's versatility, as both a fighter and ground attack aircraft, multiplied its strategic impact. While German fighters were designed for air-to-air combat and struggled with ground attack missions, the P-47 excelled in both roles. Equipped with external pylons capable of carrying bombs, rockets, and additional fuel tanks, the Thunderbolt could clear enemy fighters from the sky, and then systematically destroy ground targets with devastating effectiveness. The psychological impact on German ground forces was profound. The same aircraft that dominated the skies above them could also deliver precise, overwhelming attacks on their positions, supply lines, and infrastructure. Major Heinz Beer, one of Germany's most successful fighter pilots, with over 200 confirmed kills, would later reflect on the impossibility of the strategic situation. It wasn't that the American pilots were better than us, though many of them were quite good. It wasn't even that their aircraft were necessarily superior. In every category, our fighters could still turn tighter and climb faster at low altitude. The problem was that there were so many of them, and they kept coming. We would shoot down 5 Thunderbolts in a morning mission, feel victorious, and then face 15 more that afternoon. They had aircraft to waste. We did not. They had pilots to waste. We did not. They had fuel to waste. We did not. It was like fighting the ocean. You might win individual battles against the waves, but the tide was unstoppable. The technological sophistication of the Thunderbolt revealed itself in combat details that German intelligence had failed to anticipate. The aircraft's electrical system was designed with multiple redundancies that kept crucial systems operational, even after sustaining heavy battle damage. The radio equipment provided clear, long-range communications that allowed for coordinated tactical operations impossible with German radio equipment's limited range and reliability. The gun sight system incorporated advanced computing mechanisms that automatically calculated lead angles and bullet drop, transforming average pilots into deadly accurate marksmen. Perhaps most devastating was the Thunderbolt's ability to absorb punishment and continue fighting. German pilots were accustomed to achieving kills with relatively few hits. Their cannon shells were designed to destroy aircraft structure with explosive force. But the Thunderbolt's massive structure, self-sealing fuel tanks, and armored cockpit meant that attacks which would have downed German fighters merely damaged systems that had been designed with multiple backups. Combat reports from German pilots contain increasingly frustrated accounts of Thunderbolts absorbing dozens of hits and continuing to fight effectively. Lieutenant Colonel Hub Zemke, commander of the 56th Fighter Group, developed tactical innovations that maximized the Thunderbolt's advantages while minimizing its weaknesses. His pilots learned to fight as coordinated teams, using their superior firepower and diving performance to engage German formations from positions of advantage, then using their superior high-speed handling to escape before German fighters could respond effectively. These weren't desperate improvisations, they were systematic tactical evolutions based on scientific analysis of aircraft performance characteristics and combat effectiveness data. The intelligence reports flowing back to German high command painted an increasingly desperate picture. By early 1944, Luftwaffe units were reporting engagement ratios of 3 or 4 American fighters for every German aircraft, odds that made survival, let alone victory, increasingly unlikely. The experienced pilots who formed the core of Luftwaffe effectiveness were being killed or wounded at rates that made replacement impossible. Meanwhile, American P-47 units were operating at full strength, with experienced pilots training newcomers in combat-proven tactics. The fuel crisis that began affecting German operations in late 1943 made the Thunderbolts' abundance even more crushing. While German pilots were limited to minimal training flights and carefully rationed combat missions, American Thunderbolt pilots could afford extensive gunnery practice, formation training, and tactical exercises. The difference in preparedness was visible in combat. German pilots increasingly found themselves facing opponents who had hundreds of hours of recent flight time and extensive gunnery training. The industrial capacity that produced the Thunderbolt was itself a weapon of warfare. The same factories that built P-47 seconds were simultaneously producing bombers, transports, trainers, and support equipment at scales that dwarfed anything possible in wartime Germany. The aluminum that went into a single Thunderbolt represented more metal than many German factories received in a month. The fuel consumed in training a single American pilot exceeded the allocation for entire German squadrons. This wasn't just military production, it was the systematic conversion of the world's largest industrial economy into a weapons manufacturing apparatus. The escort missions that began in earnest in 1944 revealed the full strategic impact of Thunderbolt deployment. American bombers that had previously suffered devastating losses to German interceptors suddenly found themselves protected by formations of P-47 seconds that could not only defend against German attacks but also pursue and destroy German fighters attempting to disengage. The Luftwaffe found itself fighting a two-front air war, defending against bomber formations while simultaneously trying to survive against escort fighters that were increasingly dominant in every category of combat performance. The ground attack capabilities of the Thunderbolt added another dimension of strategic devastation. German supply lines, airfields, and transportation infrastructure came under systematic attack from aircraft that combined the firepower of heavy bombers with the precision of fighters. Railroad systems that had functioned effectively despite Allied strategic bombing campaigns found themselves unable to operate during daylight hours due to the constant presence of Thunderbolt formations armed with bombs and rockets. Colonel Donald Blakesley, one of the most successful American fighter commanders, would later describe the transformation of aerial combat. The Thunderbolt changed everything. Before the P-47, we were fighting individual dogfights, pilot against pilot, aircraft against aircraft. With the Thunderbolt, we were conducting systematic warfare formations of aircraft, working together with coordinated tactics, overwhelming firepower, and logistical support that let us maintain continuous pressure. The Germans never adapted to industrial warfare in the air. They kept thinking in terms of individual combat when we were conducting systematic destruction. The maintenance and logistical advantages of American forces became increasingly apparent as the war progressed. While German aircraft became increasingly difficult to maintain due to parts shortages, fuel limitations, and overworked maintenance crews, American P-47 squadrons operated with logistical abundance that seemed almost miraculous. Aircraft that sustained battle damage could be repaired quickly, using abundant spare parts supplies. Pilots who needed additional training could receive it without impacting operational readiness. Squadrons could experiment with new tactics and equipment without worrying about resource limitations. The training pipeline that produced Thunderbolt pilots represented another aspect of American systematic superiority. While German fighter pilot training had been reduced to bare minimums due to fuel shortages and instructor losses, American training programs continued to operate at full capacity. New pilots arrived at combat units with extensive gunnery training, formation flying experience, and tactical knowledge that exceeded what many German veterans had received in their entire careers. The psychological impact on Luftwaffe morale became a significant factor in combat effectiveness. German pilots increasingly reported feeling overwhelmed, not just by American numerical superiority, but by the apparent inexhaustibility of American resources. Shot-down Thunderbolts were replaced within days. Damaged aircraft were repaired with parts that seemed to appear magically. American pilots seemed to have unlimited ammunition for training and combat operations. Oberst Johannes Trautloft, one of Germany's most experienced fighter commanders, filed a report in March 1944 that captured the hopelessness of the strategic situation. The American Thunderbolt represents more than just another enemy fighter aircraft. It represents the industrial capacity of a nation that can afford to build fighters heavier than our bombers, arm them more heavily than our ground attack aircraft, and deploy them in numbers that exceed our total production capacity. We are not fighting individual pilots or even squadrons. We are fighting the manufacturing capacity of Detroit, the aluminum production of Pittsburgh, and the pilot training facilities of Texas and Arizona. This is not warfare as we have understood it. This is industrial destruction on a scale that makes traditional military thinking obsolete. The reconnaissance photographs that had once shown American Thunderbolts as objects of derision now revealed the full scope of American deployment. German intelligence estimated that by mid-1944, American forces in Europe were operating over 1,500 P47 seconds in combat units, with additional hundreds in training and replacement pools. The mathematical reality was inescapable. Germany was producing fewer than 200 fighters per month of all types, while facing an opponent who could deploy Thunderbolts alone in numbers exceeding total German fighter strength. The combat reports from German pilots became increasingly desperate and revealing. Hauptmann Anton Haeckel, flying with JG-11, described an engagement over northern France. We climbed to intercept what intelligence reported as a small formation of American bombers. Instead, we found ourselves facing more than 60 Thunderbolts flying escort. The sky was black with them, massive, powerful aircraft that dove on us like falling anvils. My wingman was shot down in the first pass, his FOA-190 literally torn apart by the concentrated fire of multiple 50 caliber guns. I managed to escape only by diving to treetop level and using every gram of fuel in desperate, evasive maneuvers. This was not aerial combat. This was industrial execution. The versatility of the Thunderbolt, as both fighter and bomber, created tactical situations that German commanders found impossible to counter effectively. Formations of P-47 seconds could engage German interceptors in air-to-air combat, defeat or drive them away, and then transition to ground attack missions against the same airfields from which the German fighters had taken off. This dual capability meant that German air forces faced simultaneous pressure on their operational aircraft and their ground infrastructure. The fuel and ammunition consumption of Thunderbolt operations revealed another dimension of American logistical superiority. Each P-47 consumed fuel at rates that would have grounded German squadrons within days. Yet American units operated with fuel allocations that seemed unlimited. The 50 caliber ammunition expenditure of a single Thunderbolt squadron exceeded the total small arms ammunition production of many German factories. This wasn't just abundance, it was systematic resource dominance that made sustained operations possible on a scale unprecedented in warfare. The evolution of American fighter tactics around Thunderbolt capabilities demonstrated systematic tactical innovation that German forces struggled to counter. The Zemke fan formation developed by Colonel Hub Zemke allowed P-47 formations to engage targets with overlapping fields of fire while maintaining mutual support. The bounce and extend tactics pioneered by Thunderbolt pilots used superior diving speed and high-altitude performance to engage on favorable terms and disengage before German fighters could respond effectively. The industrial infrastructure supporting Thunderbolt operations included not just aircraft production but the entire supply chain of specialized equipment, training facilities, and maintenance capabilities. The 50 caliber ammunition required specialized production facilities. The R-2000, 800 engines required precision manufacturing capabilities and exotic materials. The pilots required training facilities equipped with advanced aircraft and unlimited fuel allocations. This entire system operated at full capacity, while German forces struggled with shortages of basic materials and equipment. Major Georg Hermann Greiner, operations officer for JG-54, filed a tactical analysis in May 1944 that revealed the hopelessness of the situation facing German fighter forces. The American Thunderbolt has systematically negated every tactical advantage we possessed. Our superior climb rate means nothing when they engage from 30,000 feet. Our superior turning ability means nothing when they refuse to turn fight. Our firepower advantage means nothing when they can absorb our cannon hits and continue fighting while their 8 machine guns destroy our aircraft with single bursts. Most importantly, our pilot experience means nothing when they can afford to lose pilots and aircraft while we cannot. They are fighting an entirely different kind of war, one where industrial capacity matters more than individual skill, where systematic tactics matter more than heroic improvisation, where sustained logistical support matters more than temporary technological advantages. The ground support capabilities of the Thunderbolt transformed the battlefield in ways that German forces had not anticipated. P47 seconds equipped with bombs and rockets could deliver precise attacks against point targets while maintaining the ability to engage enemy aircraft. This dual capability meant that German ground forces faced air attacks from aircraft that could also defeat any air cover provided by the Luftwaffe. The psychological impact was devastating. German troops learned to fear clear skies that would bring Thunderbolt formations hunting for targets of opportunity. The production statistics became increasingly overwhelming as 1,944 progressed. American factories were producing P47 seconds at rates exceeding 1,000 aircraft per month, while simultaneously producing other fighter types, bombers, transports, and trainers in comparable numbers. The total American aircraft production in 1944 exceeded 90,000 aircraft, more than Germany had produced in the entire war to that point. This wasn't just numerical superiority, it was industrial domination on a scale that made German resistance increasingly futile. The technological sophistication built into each Thunderbolt represented manufacturing capabilities that Germany could not match even under peacetime conditions. The turbo-supercharged R2800 engine incorporated metallurgy and precision manufacturing techniques that required industrial infrastructure and materials science knowledge that exceeded German capabilities. The electrical systems used components and design principles that reflected American advances in electronics and industrial production techniques. The hydraulic systems incorporated reliability and performance standards that German manufacturers could not achieve with available materials and manufacturing capacity. The pilot training programs that prepared American aviators for Thunderbolt operations represented another dimension of systematic superiority. While German pilot training had been reduced to bare minimums, American programs continued to operate at full capacity with unlimited fuel allocations, advanced training aircraft, and extensive gunnery practice. New American pilots arrived at combat units better prepared than German pilots with months of combat experience. This training advantage compounded over time, as experienced American pilots survived to train newcomers, while German veterans were lost at unsustainable rates. The final revelation came in the form of a captured document, a personal letter from Oberst Walter Osau, one of Germany's most successful fighter pilots and tactical innovators, to his wife, dated June 15, 1944, and found in his personal effects after his death in combat against Thunderbolts. My dearest Elizabeth, I write this knowing that I may not survive to see the end of this war, not because I have lost my skill or courage, but because we are no longer fighting a war that can be won through individual heroism or tactical brilliance. The Americans have created something unprecedented. They have industrialized warfare itself. Their Thunderbolts are not just aircraft. They are the physical manifestation of an industrial capacity so vast, so overwhelming, that it renders our traditional concepts of military strength obsolete. We train to fight pilots. They trained to destroy industrial systems. We built aircraft to win dogfights. They built weapons to dominate skies. We fight with the desperate skill of craftsmen. They fight with the systematic efficiency of engineers. I have shot down over 100 enemy aircraft, but today I faced 40 Thunderbolts over Normandy, and I finally understood that we cannot win. Not because our aircraft are inferior, though increasingly they are, but because we are fighting the productive capacity of Detroit, the aluminum smelters of Pittsburgh, the oil refineries of Texas, and the training facilities of Arizona and Florida. We are fighting not just American pilots, but American industry, American logistics, American systematic engineering applied to warfare. Individual courage cannot defeat industrial mathematics. We cannot win. In the end, the story of German pilots laughing at the P-47 Thunderbolt until its 8:50 seconds reigned lead on them, represents more than just the evolution of aerial combat or the triumph of one aircraft design over another. It represents the fundamental transformation of warfare itself from a contest between individual warriors and tactical innovations to a systematic application of industrial capacity, technological sophistication, and logistical abundance. The Thunderbolt wasn't just a fighter aircraft, it was industrial warfare incarnate, a physical manifestation of America's systematic conversion of its entire economic capacity into a weapons production system that could sustain losses, maintain operational tempo, and systematically destroy opposition through sheer, overwhelming abundance of resources, technology, and trained personnel. The German pilots, who initially dismissed the ungainly American fighter as a flying bathtub, were not wrong about its individual characteristics. They were wrong about the nature of the war they were fighting. They prepared to fight a war of individual skill and tactical innovation. America fought a war of systematic industrial destruction. The mathematics of that contest were never in doubt. Only the timeline for its inevitable conclusion remained to be determined.